Hi everybody, I'm Kate Spangler and I'm the lab coordinator for CEE. And today I'm going to be here to show you how to prep your samples once you get back to the lab. First, you'll take out the 60 ml amber bottle from the cooler that you have nicely labeled on the side, wink wink. And we're going to prep the IC sample first. And IC is for the ion chromatograph, and that is going to analyze your anions, such as fluoride, chloride, nitrite, nitrate, bromide, sulfate, and phosphate. With a fine tip marker, Sharpie marker, you're going to label your sample ID across the side of the vial. Now, you'll take your sample bottle that has your already filtered sample of 0.45 micron, and you'll slowly invert it a couple of times because you want to have a homogeneous sample. And then carefully pour your sample into the vial, approximately a thumbnail's width from the top. And this, which is probably hard to see, is the stopper. And the stopper you want to put in with the stem sticking up. And there is a hole through this, and that's where the auto sample needle goes down through. So you have to be very careful when you put this in that you don't stick your face over top of the sample vial. Keep your head back, because as you press down, some excess sample may pop out of the top. And then you want to press this down until it's flush the top of the vial. And now your sample is all set to go. So then what you'll do is put it in a sample rack and place it in the refrigerator. And it should be analyzed within 48 hours in order to get good nitrate and nitrite results. And congratulations, there's your IC vial. Now we're going to prepare our dissolved organic carbon sample, otherwise known as DOC. To do this, we take a TOC vial, which is total organic carbon, and it's a special vial that works on the auto sampler for the analyzer. And we need to label this first before we put our sample in. So we'll label the vial, and you want to put the tape near the top of the vial, otherwise it won't fit into the auto sampler. So label with your sample ID, and then take your filtered sample, invert several times to homogenize, and then pour the sample carefully into the vial. Now, this analysis at most needs 20 mils, so you don't need to fill it to the top. This is a 24 mil vial. Okay. Now that we have our sample in the vial, we need to preserve it. So we need to acidify it with hydrochloric acid. Now that we're back at the chemical hood, this is where we're going to add concentrated hydrochloric acid to our dissolved organic carbon sample. And we're going to do this by using a disposable glass Pasteur pipette. And you want to make sure that your sample is in a test tube rack, because you don't want to spill your sample. So first, uncap your sample, and then next, carefully uncap the acid, and carefully draw up just a little bit of acid, and then add 3 to 4 drops. 1, 2, 4. And then dispose of the used pipette tip into proper waste disposal. And now we just invert our sample a few times to mix. And that helps to release any of the trapped inorganic carbon that might be in the sample. And now you have the dissolved organic carbon sample prepared. And now for the last sample that we're going to prepare from the filtered bottle that we brought back from the field is for COD, chemical oxygen demand. And for this, we use reagent vial prepared by the Hawk Company. Make sure you're wearing gloves and glasses and a lab coat. This contains mercury. The first step is to label the vial. And these vials don't really give you much space to put a ID number on, but just do your best to write in that small area right there. And the neat thing about the Hawk kits is that they tell you everything that you need to do right here in an illustration. So the first step is to invert your vial a few times, and that's to get the reagent working. And the good tip here is always hold by the cap, because the glass is going to turn really warm as the chemical reaction is occurring. And then you'll take your sample and invert it to homogenize like before. And then slowly pipette 2 mils and add it to the vial. And dispose of your pipette tip. Recap your vial and invert again a few times. And again, it's going to be still very hot. So just hold it by the cap. And now that we have our sample prepared, we have to go to the dry block heater where it's going to digest for 2 hours at 150 degrees Celsius. We're coming into another chemical hood, and in this hood we have a standard heat block. And the block, we're going to set the temperature to high, which is 150 degrees Celsius for this digestion. I did this prior to starting this because it takes a while to heat up. So now we'll take the vial that we already sampled or added our sample to, and we're going to wipe it clean with a Kim wipe. And then we simply place it in the dry block in one of the holes. And then we wait 2 hours as it's digesting at 150 degrees Celsius. Okay, and now 2 hours have gone by, and so it's time to turn off the heat block and carefully grab the vial from the cap, not the glass because it'll be really hot, and place it in a metal rack to cool. And it takes about 20 minutes until it's at room temperature. Now that our vial has cooled to room temperature, we're going to take it and invert it a few times and then wipe the sides with a clean Kim wipe. Then we're going to place it in a Hawk spectrometer, and it automatically recognizes the test that we're performing, and which is the low range COD, and we got a result of 45.5 milligrams per liter COD. So record your result in your lab book and you're all set to go. Since the reagent contains mercury, we need to properly dispose of the reagent into a properly labeled waste container. Wearing your PPE, carefully dump the waste into the container. And so now I'm just going to rinse the vial with Millie-Q. And pour the waste into the container. And the vial itself can just be disposed of in a broken glass container. And the cap can be thrown away. Now we're going to prep our trace metal samples that you took in the field. The first one is for dissolved trace metals, and this is the one that you filtered. So you used a 0.45 filter and filtered your sample into this vial that is already labeled. And this sample was your total dissolved metals. And this one is a raw sample, meaning it was not filtered, it was just taken straight from the street. Each of these is going to be acidified with 1:1 nitric acid. The only difference is the dissolved sample will only get 6 drops of acid, while the total sample will get 10 drops. And the reason for that is that the total sample has more particulate matter in it, and in essence, the acid should dissolve this and make it more in solution. So now, again, we're under a hood, because you don't want to do this in open air because of the volatile gases that will come up. So now we'll carefully undo our sample and carefully uncap the nitric acid and water sample bottle dropper. And since this is just a double check, always want to double check, this is the dissolved, so this was the filtered, so it's going to get 6 drops. 1, 2, 3, 4, 5, 6. And then we'll cap and invert the sample to mix. And again, even though we know this is the total, always double check. Okay, total metals. So this one requires more acid. So we're going to add 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, invert your sample. And now these samples are both at a pH below 2, and so they're preserved, and they're all set to go to be analyzed on the ICP OES. So now we'll carefully undo our sample and carefully uncap the nitric acid and water sample bottle dropper. And since this is just a double check, always want to double check, this is the dissolved, so this was the filtered, so it's going to get 6 drops. 1, 2, 3, 4, 5, 6. And then we'll cap and invert the sample to mix. And then again, even though we know this is the total, always double check. Okay, total metals. So this one requires more acid. So we're going to add 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, invert your sample. And now these samples are both at a pH below 2, and so they're preserved, and they're all set to go to be analyzed on the ICP OES. Our final sample preparation is for TSS, total suspended solids. And this was the sample that you collected into the 1 liter bottle at the field. The first step is to pre-rinse your filter. And the filters that we're using are glass fiber filters that are a nominal 1.2 micron in pore size. So using tweezers, you want to try to grab one filter, not more than one. Sometimes it's hard to see. And you want to put it wrinkle side up. And it may be hard to tell, but this side has more wrinkles than this side. And then you'll take your filter and then wet the top of your filtration apparatus and place the filter on top. You'll take the funnel, which has a rubber gasket on the bottom, and you'll place it on top and apply equal pressure, not a lot of pressure, but just equal pressure on the top of the funnel, and then just gently close the ring down. And now for standard methods, you rinse the filter with milli-Q water, which is just ultra pure water, for 3 times with 20 mils, approximately 20 mils of water each time. So I'm going to add about 20 mils. Doesn't have to be exact for this part. And our filtration apparatus is connected to a vacuum pump. And so with the hose connected, and as well this small rubber gasket should be, make sure that that's on, or else you will not get a tight vacuum. And now we'll turn on the vacuum. And then it filters through. Now we're going to repeat that process 2 more times. And on the final time, I generally tap the funnel around to try to get all the droplets off the side. And now you have a rinsed filter. And the next step is to take an aluminum pan and label it with your sample ID. And then carefully unscrew the funnel. And with your tweezers, you want to carefully remove the filter from the top of the filtration funnel. And gently lay it in the pan like this. We take this sample to the oven, which is set at between 103 and 105 degrees Celsius. And then it has to dry in there for at least 1 hour. And here's our oven that's already been turned on and is heated to 103 degrees Celsius. And then we're just going to place our pan plus the filter in the oven for roughly 1 hour. So over an hour has passed, and it's time to remove the pan and the filter from the oven. Carefully grab the pan, and you want to place it in a desiccator to cool. And this process is so that no added moisture no moisture is added to the filter during the cool down process. The desiccant keeps any water from absorbing onto the filter. So we'll keep that in there for roughly 15 minutes. Now that our sample has cooled, we need to record its weight. So over at the analytical balance, I'm going to make sure all of the doors are closed, and then you're going to press 0 to zero the balance. And then we'll open the door and weigh our pan plus our dry filter. And we'll wait for the reading to stabilize, and then we'll record the mass. Now that we have our initial weight of our pan and our filter, it's time to actually filter our sample. So we're going to take our 1 liter sample bottle, make sure that that's within reach, and then again we're going to wet the top of the filtration disc and apply the same dried filter that's been washed to the top. And then we'll apply pressure again and add the funnel. Now for standard methods, like I said before, we want to try to get between 2 and 200 milligrams of solids onto the filter. And obviously it's kind of difficult to guess how much volume that might take. So I recommend just working in increments when you add your sample to your filtration device. And then once you turn the vacuum on, just observe how quickly the sample is filtering. And an important thing to remember is that you need to know exactly how much of your sample you're filtering. So you want to make sure you have a piece of paper to record that. So we're going to invert our sample a few times. And we'll use a graduated cylinder. I generally start with a known amount. So I know that there's 500 mils. And now I'm going to add a little bit. And then I'm going to turn the vacuum on. And that went through pretty quickly, so I'm going to add a little bit more. And apparently it's still under vacuum because it's still going without having to turn the vacuum on. And then we just keep adding more until you can visibly see a nice even layer on top of the disc, on top of your filter. An even layer of sediment or solids, suspended solids. And I'm turning the vacuum on because I think it needs a little bit of extra pull. Okay, it seems like that the flow is starting to decrease, so I'm going to stop. And now I'm going to see how much sample I actually added. So I knew I started with 500 milliliters. And now I look down, and you want to look at eye level. There's 190 left. So simple math, 500 minus 190 will be the total volume that I added. We just need to rinse the sides of the funnel. And we do that with a milli-Q squirt bottle. Tap the sides again to get all of the droplets off. And once your vacuum pump is off and you know not see any more droplets hanging onto the sides of the flask, remove the hose. Carefully unscrew the funnel. And take your tweezers and carefully peel the filter off and place it in the same pan that you started with. And so now you can see how many solids we collected. Now we're going to take this back to the oven where it's going to dry at 103 degrees Celsius for approximately 1 hour at minimum. After an hour, I removed our sample and placed it into the desiccator for it to cool. And now we just take our final measurement. So again, we're back at the balance. Remember to tare the balance before you measure put your sample on. Wait for the reading to stabilize and record your final mass. And then you perform the calculation in standard methods, and you'll be able to determine the total suspended solids of your water sample.